Hey guys, I hope you're all doing really well this week. This is a Dell Latitude E7440, which I bought, and it has a motherboard fault. I've removed the motherboard already. I didn't get a keyboard with it, but I do have a screen. So what I'm going to do is I'm going to take some pictures of the motherboard. I'm going to bring it onto the screen and we're going to start troubleshooting and see if we can get this back to life.
And this is what the motherboard looked like when I scanned it in. Now you may remember on a video, I think it's about 2 months ago, we had one of these motherboards and I managed to get it working. There was a short with one of the capacitors on the main power rail. Now hopefully it's similar with this and we can get this back working again. But what I'm going to do first is I'm going to check at the input section and just make sure we've no shorts there, and then I'm going to input voltage and just see what happens when we bring power to it. But the first step is to locate the DC input jack, which is here. So we've PJP DC1. I'm going to work out what each of these pins do, and then we're going to follow along in diode mode and just verify that the input section is okay. Now I've zoomed in on the input jack, which is PJP DC1. We need to know which one of these pins carry in our positive input and which one is ground. And usually with the Dells there's an ID pin as well. Well, I found a schematic. I actually had this from the last top that I worked on. So we've PJP DC1, which corresponds to PJP DC1. There's 5 pins on this and I'm going to mark them in on my actual motherboard. So here we go, 1, 2, 3, 4, 5. So let's get a quick look and see what they do. Pin number 1 comes over to here and then goes up, and as you can see it's marked as ID. So this is the ID pin. Pins 2 and 3, this is a little bit difficult to see, but just follow along the line. They're joined together here. That's pin 2 and 3 connected to here, and then they come up and onto PL4, which is an inductor, and that corresponds to this inductor right here. So that is our positive input. And then we can see pins 4 and 5, again this is a little bit difficult to see, but pins 4 and 5 are joined together here and they go to ground. So let's mark in what each of those does. Okay, so now that we know what each of them does, I'm going to follow along our positive path and just check for shorts on the input section, starting at PL4. Now we've seen on the schematic that our positive input, which is on pins 2 and 3, goes first to PL4. So let's just mark that in. So here's PL4, and the first check we want to do is just make sure there's no short at the DC input jack. So I'm going to put my multimeter into diode mode. I'm going to put my red probe to ground, my black probe to PL4, and when I measure there I find that it measures 0.670. so there is no short at our DC input jack. That is fine. Quickly going back to our schematic for a second, we can see that after PL4 the next component in line is PQ4. So let's see if we can find that. So where's PQ4 on our actual motherboard? Well, if I zoom out here and just scroll down a small bit, you can see PQ4 is down here. So after our inductor, it follows along this track here and onto the source pins of PQ4. Let's mark that in. I've introduced my multimeter in diode mode again. I just want to take a measurement at the source pins here. Now this should be continuous with the inductor, so it should have the same measurements, but I'm just going to check it here just in case. So with my red probe on ground, my multimeter in diode mode, I place my black probe to the source pins of PQ4 and we measure 0.670. So that's fine also. Back to our schematic, we can see that after PQ4, if PQ4 is turned on, our DC input voltage should come through and it's then labelled as plus DC in SS. So if I search for that further down the schematic, we can see that it then comes onto the 4 drain pins of PQ700. So let's see if we can locate PQ700. I've located PQ700, it really wasn't that difficult. They're closer together on the actual motherboard than they are on the schematic. So after PQ4, our voltage comes up around here and onto the drain pins of PQ700. So let's just mark that out. So what I want to do here is do a check in diode mode between the two MOSFETs. So to do that, I place my red probe to ground, I place my black probe to the drain pins of PQ700, and what I measure there is 0.614. So we've no short between the MOSFETs either. After PQ700, our voltage should then come on to PR700. Let me just mark out that path here. And this is our main power rail. So you may remember on the last video that we looked at with a Dell Latitude E7440, we found a short at this point. And obviously you're happy to find a short at that point because it's usually a blown capacitor or something easy to fix. So what I'm going to do is I'm going to take the same measurement from PR700. So once again, with my red probe to ground, my multimeter in diode mode, I place my black probe to PR700, and what I find is it measures 0.566. So what does that mean? Well, that means that it's not short at this time, so we're going to have a different fault. So what I'm going to do at this stage, we've established that there's no very obvious short on the input section. So I'm going to bring power onto this laptop from my DC power supply, and we're going to see what happens. So the next step is to bring some power onto this motherboard and see what happens when we try and power it on. Now I've checked online because I don't have the power adapter with this. This is the power adapter that suits this laptop. It's 19.5 volts input. As you can see there, it suits the Dell Latitude, a number of these different ones, but it includes the E7440. So how do I bring 19.5 volts onto the laptop? Well, you've probably seen me doing this before. I introduce my DC power supply. I connect my black wire to ground, and I connect my red wire to where the DC input comes in. The easiest place for me to do this was just at this nice little inductor PL4 right here. And then I set it to 19.5 volts. I didn't bother using a current limit because I've already established that there doesn't seem to be any short on the input, so it's safe enough. So let's see what happened when I tried to power it on.
Back to the real world, you can see that I have my DC power supply now hooked up to my motherboard. So this is my black wire from my DC power supply. I've just soldered a wire onto the board here. And this is my red wire from my DC power supply, and this is soldered onto PL4. So as you can see, it's drawing about 11 milliamps, which is in and around where it should be. Thankfully, they do have a button on this board, so I don't have to go jumpering anything with a tweezers. So I'm going to press the button and see what happens. So the power button is in here, so I press it on, and okay, immediately it's gone to 275 milliamps. Oh. And straight back down, so it's shutting itself down, and we have a flashing code by the look of it here. So let's get a look at that. Okay, it doesn't seem like there's any pattern. It just seems like it's flashing over and over and over. Let's see if I can get in on that. Yeah, it's just flashing, there's no pattern. Because usually with these, if there is a diagnostic code, it'll give you like 3 white, 4 amber or something like that, and then it'll tell you what exactly it's for. But let me check that out and see what that exact, the constant flashing white light is meant to diagnose.
In the Dell Latitude E7440 owner's manual, there's a page called Device Status Lights. Now what this does is it gives us a list of faults that are indicated by a specific set of flashing lights. Now I couldn't see that there were 3 individual LEDs on that board, and they actually correspond to the storage LED, the power LED and the wireless LED. As you saw from the previous part of the video, I only just looked at it, saw that there was white light flashing, and I've come to the manual to see what that's meant to indicate. But we actually need to see which of those LEDs are flashing and which are solid, because for example, if we have a storage LED that's blinking, a power LED that's solid and a wireless LED that's solid, that indicates a processor failure. But until I can determine which LEDs are flashing, I'm not going to know what the fault is. Now before doing anything else, I decided that it might be wise to double check the memory that I was using, because this didn't come with any memory, I had to supply it, and try reseating the memory, because a lot of those flash and error codes are to do with memory. And when I was looking at the memory, I took a look at the socket. And if you can look at this socket here, I'm just going to zoom in a little further. I couldn't really believe what I was looking at. And I hope you can all see that in the picture here. So it looks like somehow these pins have been soldered together. So I decided to take a closer look on my microscope. And this is the view of those same DIMM sockets with my microscope. What the hell is going on here? It looks like somebody got a soldering iron and literally dragged it across these and connected them all together. That's the only thing I can possibly think of as having happened. Is it the case that one of the pins they thought was loose, and then they tried to drag the solder across all of them without using any flux? Post in the comments below if you know what's going on here. But I think that may be something to do with our fault, because there's multiple pins there, as you can see, that appear to be connected to each other. So I'm going to see if I can clean this up first before going any further. I temporarily put the motherboard back into the chassis just to see which LEDs were lighting up, and sure enough, it's the storage LED that's solid, the power LED that's blinking, and the wireless LED that's blinking. So it won't be a shock to anybody if you viewed the start of this video to see that the memory modules are what the system is detecting that is having the problem. Next, I doused the pins in a little bit of flux and I tried to separate them out. So this is the way I did it. I got a reasonably big chisel solder tip and I just went one by one just to try and solder them back into position and to get rid of the bridges between them. Now after I finished resoldering the pins, I just went along one by one with I've got a needle probe that I made myself on one of the multimeters. So what I did was I just dug out the dirt between them and just made sure that none of the pins were moving off their solder pad. So you can compare this to the image from before. You can see where there's no bridges and where I've tried to get a reasonably good solder connection for each one. I cleaned out those pins and checked the connections as best I could, but when I tried to plug it back in again, it did the same thing, unfortunately. So disconnecting those bridges of all of the pins on both of the sockets has not had any influence on it. And I'm still wondering if those bridges were created in the process of trying to sort out what the original issue was. So what I decided to do at this point was just to take a couple of measurements on the board just to make sure that the RAM is getting voltage. So I decided by starting to measure at the main power rail. So I introduced my multimeter in volts DC this time, and I placed my black probe to ground, and I placed my red probe to where we identified as being the main power rail earlier on. That was a PR700. And when I did that, I measured 19.50 volts. So our main power rail is reading the correct voltage. Having established that the main power rail was reading the correct 19.5 volts, I then located and identified this inductor as possibly being the inductor that carries the 1.35 volts for our DDR3L. It's written down as PL200. So when I checked here, I placed my probe to this inductor. Without pressing the power button, this read 0.000. However, when I pressed the power button, it went up to 1.369, and after 2 seconds, it went back to 0 volts again as the machine shut off. So it seems like it is reading the correct voltage. 1.369 is a little higher than the 1.35 that we usually expect for DDR3L, but I don't think that's the issue. I think what's happening is it's bringing up the correct power and then it's detecting a fault and then everything is shutting down. And just to confirm on the schematic, PL200 is this inductor, and it is on the 1.35V_MEN_P. This is the memory DDR3L voltage, which is 1.35. Like I said, it's a little bit high on this, but I think it's within spec. Unfortunately, that's all the progress I was able to make with this laptop this week, guys. I put another 3, maybe 4 hours into trying to tidy up those DIMM sockets. I even removed the second one in case there was some sort of internal fault and left just DIMM socket A, but it was still bringing up the same fault, unfortunately. Now I have gained a bit of experience in just, working with the pins in the DIMM sockets and, soldering it and different things like that, but it has been frustrating, I'll be honest with you. But that's as far as I can bring it. If there's anybody has any other suggestions as to what we can do with this or what to do in this scenario, because we come across this quite a bit, please post in the comments below. Just final thought before I end the video. I was reviewing the raw footage that I have for making my videos and uploading it to YouTube, and I spotted this as I was going back through it. Now, what I originally pointed out was that the solder was dragged along the tops of these pins, and some of them were making connection like these ones here. Obviously, as you saw in the video, I got rid of those, but still it's not coming on. But the other thing I didn't notice at the time was these lines across here. It looks like somebody has got a knife or something and cut across here. And this plastic piece of the DIMM socket has also been damaged. So I think what may have happened is, I think there may have been another primary fault, and maybe wherever this was stored, it hit off something or somebody dropped something on it, because that's very unusual. It'd have to be an object that caused this to move, that would create a line along here and, bumped off this as well. But I don't think you would do that with a soldering iron. But look, that's all the time, unfortunately, I have to work on the video for this week. I have a finite window of about 8 hours to make these in. I'd love to stay at this and maybe even remove the RAM socket and replace it and see if I can get it working that way. Has anybody ever replaced one of these? Is it even possible with the plastic? Maybe you post that in the comments below. I'd like to actually try it. I know it certainly doesn't make any sense with this laptop, but it might be interesting just to try it. That's all I got for you this week, guys. Unfortunately, not a repair this week. I will have a repair next week, otherwise I may rename the channel. Thanks for subscribing, thanks for all your comments, and I'll be back again next week.